Hello, this is the second part of chapter 2.5, and we talk about algorithm for matrix factorization and its application to the higher dimensional matrices. We will look at the 3 by 3 matrix. Okay, and again, as we discussed in the previous part, the LU factorization is the way to break down our matrix A as a product of two matrices, L and U. And they have a very special structure. For example, matrix U is your echelon form matrix, and matrix L has a very interesting form. It's called a triangular matrix, which means that it has ones in its diagonal elements and the zero above them. And to find this LU factorization, we can apply the LU algorithm, which consists only from two steps. And the step one is pretty simple. We are reducing our matrix A to the echelon form and call it matrix U. Matrix L, though, we are constructing from the multiplication factors which we calculated during reducing our matrix A to echelon form. And we've done it with a 2 by 2 matrix, and hopefully you didn't find it overly complicated, although it's getting a little bit more complicated when we increase the matrix dimensions. Okay, let's look at the 3 by 3 matrix over here, and let's try to reduce it to the LU product of our matrix, or factorize the matrix. Okay, let's start with step one of our algorithm. Let's reduce our original matrix to the echelon form. And as usually, we keep track and recording every single multiplication factor we're using to reduce our matrix to echelon form. Okay, let's start our usual reduction. So for example, our -5 will be a pivot element. So we need to get rid of like two lower elements in this column, make them equal 0. And we can do it, for example, this -10 will be our first order of business. How we can convert this 10 to 0? We can subtract the first row, multiply by some multiplication factor which give us a 0 instead of 10. And this multiplication factor, of course, will be -10. So to get the 0 in the first entry of the second column, we take every single element of this row and subtract the first element, first, second, and third elements of the first row multiplied by our factor -2. For example, for our second element of the second row, -a, we subtract our multiplication factor -2 multiplied by appropriate element of the first row, 3. For the second element of the third element of the second row, we subtract our multiplication factor multiplied by the third element of the first row, number 4. Okay, and when we conduct the calculation, we have a desired 0 in the second element of the first column. So that's really nice. That's what we're looking for. So now we can move to the third element of the first column, this 15, which we also want to convert into the 0. And again, we will use a multiplication factor, which help us to reduce it. And of course, this multiplication will be -3, because when we subtract our first column multiplied by -3, it will give us a desired 0. Okay, so we again go ahead, take every element of the third row and subtract our multiplication factor times the appropriate element of the first row. And of course, you've done it many times before, but I'd like you to show all the steps and just tell you how important it is to record all the multiplication factors. Okay, our first row is now in the tip-top shape, so we have 2 zeros, wonderful. So let's look at our second column. we have a pivot element here, -2, but below our pivot element, we would like to have a 0. So this 10 should be converted into 0. And again, we can use multiplication factor, in this case, -5. So we go ahead and subtract our multiplying factor -5, multiplied by appropriate element of the second column. And that will give us a matrix U in the echelon form. So we have a diagonal elements, which are our pivot elements, and below we have 0. Wonderful. Okay, that's our matrix U. Now let's go to the step 2 and construct matrix L. And again, matrix element have a diagonal elements equal 1, zeros above them, and we need to figure out which one are these lowest 3 elements. And again, we know that because we recorded faithfully all our multiplication factors, we can plug them in. So for example, our multiplication factor for the element A21 was -2. So we will record -2 in exactly the same position of matrix L. Our multiplication factor for the element 3,1 was -3. So we write this multiplication factor -3 in appropriate position of matrix L. Finally, our multiplication factor for element 3,2 was -5. So we will record -5 in the same place of matrix L. And that's it. As soon as we fill out multiplication factors, we're done. We have a matrix L. But I again will urge you to test your results. Let's just go take the matrix L, multiply it by matrix U, and see if it's indeed give us an original matrix. Okay, let's test. And again, this is the third extra step, which I strongly recommend you conduct every time you do LU factorization. Okay, so let's take our newly found matrix L and multiply it by our echelon matrix U. And again, because they are in this kind of like form when there is a lot of zeros, they are actually pretty easy to calculate. And as a result, look at our matrix. It does look exactly the same as the original matrix. So we did a really good job here. We have factored our matrix A into the 2 L and U components. Okay, that's all. So I would like you now go back to the chapter 2.5 and do the exercise with 4x4 matrix by using pretty much the same algorithm.